Is the current YouTube.
Okay, so I'm sharing. Let me see.
I'm only filling here and then here. The internal consistency. So they'll read the internal consistency portion from the console.
Can you see my screen?
Yes. Assess.
Okay, so let me see.
Deleted. If it was very good. For continuous.
There's a voice behind that is abstracting.
It's just right there. That's it. And then they can give the voice.
Okay, so guys, greetings everyone. So I'm Cyril. I hope you can hear me clearly.
I think Fortune should mute his microphone. You should mute your microphone.
Are we good? All right. All right, so I'm Cyril. Yeah, unfortunately, I can't be in KNUST in person. I'm in the field somewhere in Benin. So it's also going to affect. I've been waiting for some time, and my battery is already low. And since I'm in the bush somewhere, I may have to restrict everything into an hour. But hopefully, we can cover everything that we need to cover, and then I'll leave my contact information as well, and you can reach out to me anytime you want. So let's see. Can you all see? If you can, then we can go ahead.
Yes.
All right. Okay. So today I'm going to speak on data extraction. The topic was data extraction and then AI tools for performing data extraction. So I'm going to try and explain that and give you some understanding first of all, and then after that, we could, if we still have the time, we'll do a little bit of some, how do you call it? Some exercise. So at least give you an idea of what we mean by that. And we'll be covering the following things: understanding data extraction in terms of systematic reviews and meta-analysis, highlighting the challenges that usually come with data extraction, or generally even with the systematic review process. And then I'll introduce some of the AI-powered tools. Some may not be strictly AI-powered tools, but then what has happened over the past couple of, I think since ChatGPT came in 2022, has been a lot of the old tools that are available have all begun infusing AI into their workflows. So almost all the tools you have now will say we have some form of AI. And then we'll do, I'll go through sharing best practices, because again, anytime we say AI, it's important that we understand the ethics and the responsibility that comes with using AI. Because I always say that the premier responsibility is on you. You are the ultimate person. So even if you are going to use an artificial intelligence tool, you should be sure that you are still the one actually operating the system, and then you can say what exactly you've done and be responsible for that. And then we'll do a live demo, and then if you have some time, we'll also do some Q&A as well. So let's start with understanding the data extraction for systematic reviews. So I'm sure this you've gone over several times, so I'm not going to spend a lot of time here, but you know that systematic review is a research method that involves collecting literature, systematically analyzing, synthesizing a topic. And the goal is to provide a comprehensive and unbiased summary of the existing literature. And for meta-analysis, this is statistical techniques used to combine the results of multiple studies. Yes, so it often accompanies a systematic review, but not necessarily as well. All right, and it's important because usually it was a health focused thing. So for a long time, systematic reviews and meta-analysis was more for the health. So they did a lot of that, and was trying to build an evidence-based decision making, especially when you are working with policy you want to get all the evidence out there, synthesize that information, and then move forward with a particular decision based on all the data has been collected, instead of just looking at one study and using that as a basis for making any decision. And then also for reducing bias and increasing reliability. So if you just pick any study, or you just do a quick Google search and you just pick a study and then use that as the basis of any decision or a conclusion, it could just be because, oh, maybe you like the name or the title of the paper. But if you are integrating different studies, of course, then systematically, then you can also see that this is an unbiased way of looking at all the data out there. So then we can place more value on the decision you've made. And then it's also good for identifying research gaps. And this is where, for instance, I like working with systematic review. So because then it can give you a basis to start, let's say, future research. If you are maybe starting out in a field, I'm sure most of you would be graduate students. If you are starting out with your research and you don't even know where to begin or where the research gap is, a systematic review really gives you a good opportunity to be able to scan the whole field. And this time, again, it's not biased because you are doing this in a particular way, in a clearly defined workflow. So you will know that, okay, I'm not just picking and choosing what I like, but based on the workflow that I've used as well. So the key steps, and again, this I'm sure you've covered over the past week, formulating a research question, developing a protocol, doing your literature search, and your literature search will combine different databases. There are a lot of them now: Scopus, PubMed, Science Direct, Dimensions is now available, Google Scholar, all those ones. And then screening and selection of the literature out of that. Let's say you've taken three databases: Scopus, Dimensions, and maybe Google Scholar. You've put you've put in your search items. You've gotten some output. You've downloaded all those, combined them. Then you need to select the ones that are relevant and the ones that are not. And that's where we have the screening and selection process. And then you need to extract the data. So I think I joined at the end of the last session. I'm sure when the speaker was saying you do that for each study in the paper, so I realized some of you were smiling and laughing because you are looking at the amount of work involved in that, right? So you need to extract the data from each paper or from each study in a paper, and then look that and then put all that together, and then do a quality assessment to be sure that this information is actually quality information for your synthesis. And then you synthesize all that data and then interpret and report your results. All right. So this is the full process for that. So what I'm quickly going to do is to take you through something that we did recently for a systematic review. And I was saying in my field and my lab, we usually focus on trying to find a research gap. So this was a paper on the Bosumtwi impact crater, where some work has been done over the past maybe 50 years or so, right? But then the idea we started with was to understand whether there was the research gap that we could work on in the future. And the last major project that happened in Bosumtwi was somewhere in 2004, which was an international project, right? So we started with that just to look for the research gap. But actually for the systematic review paper we wrote, then the major finding we got was that there's actually an underrepresentation of African researchers, or not even African, Ghanaian researchers in geophysics studies at the Bosumtwi impact crater. So if you're in the field of geophysics, this is a striking finding because Bosumtwi it has a lot of data in terms of geophysics, unlike some other impact craters around the world. So just to explain that, the impact crater is where a meteorite smashes into the ground and creates a big hole in the ground, right? And we have this Bosumtwi as one of those places around. It's not too far from Kenya, it's 30 kilometers out, and it has a beautiful lake on it. So there's a lot of data on the place to actually prove that it is an impact crater. Unfortunately, in our finding from the study, then we realized that no, if you look at the sheer amount of work that has been done and the number of Ghanaians who actually did some work in the same field, you realize that there's an underrepresentation. So that became the main finding of our systematic review, even though that was not the initial target when we started. We were looking at the research gap. And then, of course, we found some research gaps as well. And here we used the Prisma technique. And then we used, let me see, if I do have, the search items we used were geophysics, Bosumtwi, and even for Bosumtwi, we had to vary it because there were two spellings of Bosumtwi in literature, the one with an I and one with an E. So we needed to vary that so that we could capture all the papers. Then impact crater. And then even though we added geophysics and we're looking for those kind of papers, we needed to add for each geophysical method, because it's possible the person, the items we were looking for, the literature we're looking for, may not mention geophysics per se, but they'll be using maybe a specific geophysics method. So we added the specific geophysics methods that we use, like seismic, resistivity, magnetic, gravity, which are all different geophysics methods. We made sure we added all of them, and then we ran our search. And then after running this search, we were able to get a total of 283 from Scopus, 210 from Dimensions, 47 from Google Scholar. And then we combined all that, deleted the duplicates and everything. And then we were able to also exclude review articles, technical reports, and all that. And after that, we had 49 articles left. Then we went ahead to read the AFU. So 49, which is quite manageable number, not too much if you were reading. But I know the literature reviews I've seen sometimes maybe 200 papers. And if you are going to do 200 papers, right, and extract data from all of them, I'm sure some of you are already wondering how that is going to be physically possible in your busy schedules as graduate students or as scientists, right? Okay, so then we had 3 reviewers also assess this full text independently, and there was agreement for analysis on 4 of those. And then before we extract our data, which we'll be talking about, we have to create a framework. What kind of data are we interested in? We're interested in the bibliometric material, the data, the sort of data that was gathered in geophysics. So bibliometric material, we're looking at the year of publication, the authors and your affiliations, the number and type of the type of institutions. The data, we're looking at the geophysical method used, the purpose, the approach, and the specific analysis technique they used. And then the major findings for the results, we wanted to capture that as well. And then funding agencies, because we wanted to see if we're actually funding, who was funding that kind of research. And then, of course, the journal name. So now that we had a framework, we're able to then do some analysis. And one of the interesting things we found, like I mentioned, was that there was total underrepresentation of local researchers. And then, of course, you can link that to funding, because we didn't find any single work that was funded by local governments in terms of Ghana there as well. So most of the work was funded by multiple universities across the world. So of course, then the lead researchers on all the papers were international. For most of the papers were international researchers. And anywhere we had Ghanaians, they were just attached to the project. So it was limited in number. So that was the main finding. So this would be a typical workflow for a systematic review. Yes, so for us, for me in geophysics, this is a key example that we got recently. Now that I've explained that process, we can go on to tackle the challenges that you would face, and I'm sure you've all faced this, right? You sit down for hours, even before you sit down to write a paper, maybe do a literature review and write a paper. You probably have spent time cleaning your room, preparing coffee, getting the right attire because you want to be really ready to do your work. And then you sit down for some hours, and if your friend asks, you've been writing for hours, how many words you've written? And that's where the meme comes in. We see that you've written only maybe two words, right? This is a typical thing that happens to all scientists. So it's not something that is strange. And this happens because, right, doing this systematic review or meta-analysis is time-consuming and resource-intensive, right? It takes your time. If you are even taking 49 articles and taking these articles, and for each of those articles, you need to extract data from them, or even starting with the initial search, screening and selection, and then doing the data extraction. This takes time. And those are some of the typical challenges that you face when you're conducting a systematic review. right? And then the other challenge is publication bias and data quality. If you've downloaded your data, your papers, you are looking at analyzing them, are you biased towards a specific area because again you are a human being? Maybe you like the English, and I'm sure you've all done that. You pick a paper you are trying to read, and then you realize that for each paragraph you read, you need to take a dictionary or you need to take a thesaurus and check some of the meaning of the words because it's the paper itself is complicated, right? And so if you find an easy paper that is you can understand easily, you are more biased towards that because then it makes sense. Why would you need to go through the hell of trying to understand those complicated words in another paper? And then another challenge is complexity in data synthesis. So if the data is from different sources, the data is structured differently, the analysis is different, or maybe there are composite scores or something. How do you integrate those and get something out of it? Those are the challenges that you usually face in a systematic view. All right. So that gives you at least, I wanted to start with that so that you have an idea of where we are in that process. And then we can look at the specific challenges in terms of data extraction. So now we are focusing on that part, which is what we are supposed to do today. And data extraction is the way you systematically take out the process of systematically collecting the relevant data from the studies that you've included. So now you've done your selection, your screening, you have some studies that you say, this is what I'm focusing on. How do you systematically collect the relevant data from these studies, right? And it's important because you want a lot of accuracy in how you take out that data, and you want to be consistent in how you take that data from different papers, okay? And because this will then impact the quality and the validity of your reviews findings, right? And yes, and the challenges then for this process is that, again, it is time consuming. You are taking each paper, you are looking at this paper, you are drawing out the relevant points from each paper, right? Even reading a single paper sometimes in science can be hell. Now you need to do that for, let's say, 40 papers, 50 papers, 100 papers, 200 papers. That is a lot of work, right? And then the process is also, if you are doing this manually, of course, it's also prone to human error. I've just mentioned that you could be looking at it, and because somebody called you and gave you some bad news, you are reading the paper. You've forgotten to pick something out because, life happens, something else is happening around you, and you need to focus on that. So that human error can occur. The consistency may not be there because maybe for one paper, even though you have a framework, you've picked in multiple points that you think are important, and then for the next paper, you've forgotten to pick out something, right? Again, that can also happen, and that's a challenge. You could also have your subjectivity and bias, and I've mentioned this already. You like somebody's English, but you don't like the way somebody else has written his paper because of the English or because of the way he structured his paper. So you are not really enthused about taking data from there. That can also happen. And then you are dealing with different study designs because, again, papers are written by different people from different labs, from different countries around the world, and maybe the structure of their study is even different, and we are not really interested in that. And what if sometimes they are this complex measures that somebody has used, maybe a composite measure. Recently, I think there was on Twitter, there was a whole day that they were bashing particularly a new paper in Nature that had multiple charts, so many charts that everybody was angry that how the hell do you understand? How do you go through this paper to understand what he has written? So I think people in the computer science field were really excited about the paper because then it represented the way they look at things in terms of the data analysis, data science. And then people from the biology field, because the paper was and applied using computer science for biology. Then they were angry that it was too complicated and you need to spend time to just understand the figures, right? So those kind of complex things could just come as a challenge, right? And the impact of these challenges is that then the kind of quality, the data you take from the papers, you extract from the papers, may not have the quality that you want because, again, these challenges may hamper your workflow in terms of that. And then, of course, the delays, which is very key. Scientists are doing multiple things, and then you're also supposed to write papers. And even for the papers that you are writing, sometimes you are not writing a single paper at the same time. So if a process is complicated and all these things come in, then it delays. And I'm sure you all do that. I have 4 or 5 papers that have been sitting on my PC for the past 2 years that I see I'm working on, but some of them I'm sure I've not opened for the past 3 or 4 months, right? Because maybe I started it, the process is a bit complicated and I put it down. All right. So the impact on of these challenges could be delays in review and compare. And the resource intensity. So if in to overcome these kind of challenges or to find a way around, you may need to hire more people. If you are doing a really complicated review, you may need to get reviewers. Some of this you may need to pay, or you need people to help you in screening and selecting, or even if you just have to train them before they do that, that's also resources that you are putting in. So that can complicate, can be an impact of those challenges. So the strategies generally we use to go around these challenges are: make sure you have a standardized data extraction form. So for instance, I showed with the paper we had recently, I showed you a framework for the data that we were extracting. So for us looking through all the papers, this was a template for you to extract that data and put it down in your Excel sheet so that we can then draw conclusions from that. And then you could also do training and calibration of your co-authors, other co-reviewers, so that you be sure that you are all doing the same thing before you even start working. And then double data, so you could have multiple reviewers, 3 other people, 2 other people, to help you do the data extraction so that you can compare and contrast what you've gotten, and then try to rely on some sort of consensus from the group. And then the one that we'll focus on today is then using data extraction software. Examples are AI tools, which have become ubiquitous these days across time. So we can then zoom into some of those things. So for artificial intelligence, artificial intelligence is the use of machines to simulate human intelligence, and this has become, like I say, the ubiquitous. It's all around us these days. Since ChatGPT came in, I think December 2022, there have been other forms. There's Meta AI on your phone, in your WhatsApp. It's on Facebook. I think Twitter has one, and there have even been derivations. Microsoft has one on their Windows platform, right? But AI goes beyond that. Artificial intelligence, just when you are able to get a machine to behave like a human. So using that, what happens when, for instance, you are searching in Google, you put in a word, and then there are a couple of suggestions for you to pick. There's some form of artificial intelligence mechanism behind that, or machine learning, as you say. When you go and you are probably talking about, okay, I want to watch a movie on Netflix. You go to Netflix and you see that Netflix is suggesting, based on your previous movies that you watched, the movies that they think you'll be interested in. There will be some form of artificial intelligence mechanism behind that. If you are talking with friends and you start mentioning that, oh, you need a new dress for a party, then the next time you go to Facebook, you see that there's, or Instagram, there are suggestions on shops that will give you a dress that is some form of artificial intelligence mechanism. And in all these cases, what usually happens is that there's a trained model, and the model uses data that they've already gathered on you over time. So for all this time that you've been using Facebook, or for Instagram, or for all these social media, or the websites you visited, there's a lot of data collection behind that. And these are like points on your behavior, right? And all this data is combined as a training material for an artificial learning intelligence algorithm, or machine learning algorithm. And then they learn to say that, okay, so if this guy wants this is usually what he's interested in. If he's typing this, is because he's interested in this, that kind of. So it's just, artificial intelligence seems to be a really complicated, but it's just finding correlations between your old behavior and then trying to predict what you will do in future. And this pattern recognition system can then be applied to everything. The applications in health now, for instance, to know instead of going to a doctor, or even if you go to the doctor can input your data into an AI system, and the AI system tells you what the diagnosis is. Again, because we believe that machines can be unbiased and objective when it comes to predicting outcomes, right? So that's basically what artificial intelligence is, right? So in terms of data extraction in systematic reviews, what can artificial intelligence systems do? They can automate repetitive tasks. So if I'm screening and selecting the relevant papers, I can easily outsource that to an artificial intelligence system, because this is not too complicated. I need papers that have this word in there. I don't need papers that have this word. I want to take out all conference proceedings and leave out those that are not conference proceedings. I want to take out if there's the abstract doesn't contain some words, take it out. That can easily be done, because those are repetitive tasks that can be done. And then artificial intelligence algorithms. There's some noise in the background. I'm not sure whether. Hello, there's some noise in the background. Can they? All right, thank you. Yes. So, and then it can also help in improving accuracy and consistency. So for a machine, because the moment they learn a pattern, they'll consistently keep to that pattern. Unlike human beings, where sometimes we change our mind based on what we took for breakfast or how we are feeling at a point in time, right? So in data extraction, then an AI tool can be really consistent and accurate. And then the best one for me is handling large volumes of data, which I've continuously mentioned as one of the key challenges when you are doing a systematic review, and you have to go sift through a lot of material, right? And artificial intelligence tools can do that, right? And that leads us straight to the benefit. So it makes you faster. Instead of doing something in hours, you could probably do it in 30 minutes. And now you can see that instead of writing a letter that you have to think of for 2 hours, now you tell ChatGPT to do that for you, or Meta AI or Copilot, and it does that for you in a few seconds, right? And scalability means you could deal with large data, and the moment you create a framework, you could do that for large data sources as much as possible that you have without really having to struggle with that. And then enhanced accuracy and of course cost effectiveness, because if then instead of hiring 2 or more reviewers or training people to do that for you, you could just allow the AI tool to do that, right? But of course, there are limitations to how far AI tools can go. Some of the limitations are just the initial setup. So I'm going to mention that again later. So some of the software, the initial setup may be a bit more complicated, because like one of the tools I wanted to introduce today, we weren't too sure of the programming level of everybody, because then you need to go into the back end and install set up the system in your Python framework. And if somebody is not interested in programming or doesn't know how to work from a command prompt, for instance, then that is out. So that's sometimes a challenge for some of the new ones. And then the quality of trading data. Okay, so one of the things you should be careful about with artificial intelligence tools is that it's garbage in, garbage out. Anytime somebody introduces you to some artificial intelligence tool or a machine learning algorithm, its effectiveness is limited by the data that was used to train it, right? So if it doesn't have data on a certain area, then the output in that area will be poor. I can give you a good example. One of initially when people started using machine learning tools to do recognizing human beings, like if your phone scans your face and then it opens up for you. They were very terrible for Black people, because the people who did the first systems had used a lot of white people in like Caucasians in universities, not even all Caucasians, let's say in university in the US, and maybe white Caucasian group of people. So immediately you train the model, is very successful within this group. You said it's good, it's 95%, it's 99%. And then you transfer this to an African setting, and there's no example of that because basically an artificial intelligence algorithm would work based on the data that has been presented to it. So you present an African male and it doesn't have any data on that. So then the results will be poor, right? And that's one of the challenges of artificial intelligence systems. So if you are working with a tool that was not trained maybe in a specific field or doesn't have material for that, then that could be a problem. It's one of the reasons why, for those of you probably use the ChatGPT to write wholesale without really doing it ethically and responsibly, you would realize that you can put in you write a lot of things, but then they don't really make technical sense in terms of your field. All right. And then the interpretability and then the transparency is also important because you need to be transparent, you need to be responsible. Some, for instance, the other part of this coin is that sometimes you do not know what model is being used, so you don't know how it works. So you don't know what is behind the model, right? All you know is that you feed in data and then it gives you an output. You access something and it gives you an output. Now, if you know the model behind it, that's why some of us prefer the ones that the backend is available that you can really look at. If you don't know the model behind it, then you can't really know what to tweak to get better results, right? So we just use such tools as like a black box. You just input your data and then expect a result without thinking of what it will give you later. And then some will then require ongoing maintenance and updates, which is a limitation. So I'll mention some of them and then I'll focus on the one that I want us to look at. But I think again, you will need to find some time yourself and go through some of those things. One of the tools I've seen is Ryan. So Ryan is not specifically it wasn't thought of as an AI tool. It's used for systematic reviews, but they've started integrating AI tools in there for use. There's a zero. There's the pricing includes one for not paying, but again that is limited. So the paying part is a bit maybe a bit steep for a lot of people. Then Covidence, I think some of the speakers already spoke about Covidence, which is available for you to use. But again, it's also this pricing is also steep. Strictly speaking, it's also not an AI tool because it wasn't designed specifically as an AI tool, but then they've started blending in AI in the back end for improved searches. And then Robot Reviewer, which is free, and you could just search online and use the workflow is quite simple, so you could try that. Okay, and the demo is cool. You go to the website, the demo is embedded on the homepage, so you see how that works easily. The ones that I'm most interested in is AS Review, and then the second one is SciSpace, which I'll go through in a second. So for AS Review, that is in Python. It's a really cool thing because what it can do is to actually select and screen for you. And here this was built specifically as an AI tool. So what it does is that it will select the relevant tools based on the samples you give the AI tool in AS Review, and then it will use that to then do the selection, even if you have a 200 or 1,000 papers that you need to rapidly go through and select the ones that are relevant. AS Review can do that for you. The only challenge with this is that for AS Review, you need to download the Python package and then set that up in your command prompt. But the instructions are there. You could try it if you have, or get a friend who is good in Python to set it up for you, and then you are good to go. And it's quite the workflow is quite simple, so you could try your hands at that. For the purposes of this one, the demo I wanted to try out was for SciSpace. For those of you who have some experience with this, I found this tool. I've been using it for the past 3 years. I think initially didn't have, it also started without the AI part, but now they've integrated a lot of AI behind, so that's really cool. And then I've seen that they've added pricing as well, but even the free version is still quite good. So initially you could use it a lot of the stuff for free, and they had a huge library with a lot of publications as well. So that gave you the confidence that the algorithms have been trained on a lot of previous data, academic data. So the answers are quite sharper. That's why I like using SciSpace. So I'll do the I will go on with SciSpace and do a demo in a few minutes. But before I do that, I want us to look at sharing best practices, which again I think is very important because that's the caution. Anytime you are using AI tools, it comes with a disclaimer. Okay. The best practices are that integrate the AI with human expertise. AI and humans will always be partners. So that is why I always find it sad that some, like graduate students or even scientists, other people decide that we'll just throw our topic into ChatGPT and then maybe get a lot of material or into any AI tool we have. There's always that complementary rule, especially because in certain cases, your AI tool may not be necessarily trained on material in your field. So if you decide not to check and just dump everything in there, get some material out, again, what you get out will be garbage, right? Okay. And then training and calibration. So if you have your AI tool, you want to work with this AI tool over time to make sure that it improves and it suits your field or your specific research area so that it improves upon the knowledge that it is gathering, and which is a very good thing about AI tools as well. AI tools are able to improve based on the data that you've been exposed to, right? So the more you expose data in your field to a specific AI tool, the better it gets at handling that, all right? But you should always keep at the back of your mind that you are integrating the AI with your expertise. It is not the AI leading you on your path. So if you have somebody who, let's say if you have somebody who has no knowledge in, let's say, geophysics, or for instance, the paper I started with, the impact creator paper, and they just start using AI because, yeah, I can use AI, probably they'll get a lot of things that will be totally wrong. And these days, I'm sure you've seen that circulating where there's a paper with some image or some section that is total garbage, but because maybe either the authors were not responsible enough or the authors were not knowledgeable enough, even if they get the garbage, they are not sure if it's good material or not. So it's important that it's a complementary role. And then you also need to ensure data quality and accuracy. Even if you are using an AI tool and the AI tool gives you an output, you need to cross-check. You need to do a quality control of your data. You need to get somebody else, a co-author or a co-reviewer, to help you do a validation to be sure that what you are getting is good. Because you are complementing what the AI is doing. The AI is complementing what you are doing. It's a tool. It is not the all in all. It is not the alpha and omega. It's a tool for you to work with. So you need to check and make sure that what it's giving you is accurate. And then you should also be able to combine AI tools with traditional methods. So if you know your let's say your workflow, you know your workflow for a Prisma technique in terms of systematic review, you can then combine and know where you should put in your AI tools to help you. So for instance, with my talk today, you know that the screening and selection part, the data extraction is complicated. It takes time. So here you are using the AI to reduce that workload you want to do over a short time. Okay. So if you are able to do that, then that hybrid approach works really well. But it's not like you're just going to say, okay, I think AI can do everything for me. So I'm just going to go to ChatGPT and ask ChatGPT to give me, let's say, for instance, all the I type in my topic and I get do a systematic review for this topic. What you get to probably be a lot of nonsense. All right. Okay, so those are the best practices the last part that I think is important, I didn't mention that, is you are responsible for everything that an AI tool does. So even if you are doing a systematic review, the AI tool's name is not on the paper, So initially, I remember when ChatGPT came, there was a lot of confusion in the academic space. I think somebody even wrote a paper and had ChatGPT as a co-author, and a lot of publishing houses were confused. They didn't know how to deal with this, right? But I think the general consensus now is that an AI tool is never responsible for authorship. So you cannot even list an AI tool as a co-author, right? And you as the human, you are the author of your paper. So you are ultimately responsible. So you are every, how do you call it? Every decision you make, it's on you. So you need to be able to tell us that you need to cross-check everything and be sure that what you've done is correct enough that you can defend. and not when they raise the issue, then one day you say, oh, this was generated by an AI tool, so I wasn't part of that process. Yeah. You are ultimately responsible, and I think that is important to keep in mind all the time. So so like I said earlier, my battery is really running down, so I'm going to do the live demo in a few minutes. Ebenezer, we can do the live demo right now, right?
Yes, you can continue.
Okay, so let me see if I can just open. Where do I have that? Let me stop sharing this. All right, so can you see my screen? Can you see the SciSpace homepage?
Yes.
Great. So here then, let me see if I can. Yes. Okay. So I'm going to focus on three of those let's see. Yes, three of those parts that I think are really cool for us to look at in relevant to data extraction. The first part is the literature review, and SciSpace is really cool. They used to have a lot of, like I said, they have a library full of data from journals, so it was really helpful. And what I'm going to do is I'm going to start with there's a topic I was working on yesterday. Let me see if we could do geoscience. Can geophysics be can geophysics be used as a sustainable development tool? So and then I type search in the literature review. Let me see, it's my internet. Okay, great. So now what SciSpace does really well, so it scans the internet and then gives me the first look here is it first gives me an insight from the top 5 papers it's saying around this search that I've mounted. And this geophysics plays a crucial role as sustainable development tool by contributing to various aspects of environmental preservation, resource management, and societal well-being, which is good. Then it focuses on geoscientists and what he can do. Uh, um, and this paragraph is actually very good. In addition to that, then it gives you references. So for instance, it gives me a reference, geoscience for sustainable development for the next decade. So I can actually see where it extracted that material from and see whether it's relevant to my work or not. Second one, you can see apply geophysical research for sustainable societies. Another good reference. And because I'm working on a systematic review on this topic, I can see that these are really good references. And this one is the role of the geophysicist is another good one. Then it can give you related questions that you can even type. So it can give you examples, more examples based on what you've been able to give, what you're able to give. So can geophysics help in predicting natural disasters for prevention? What role does geophysics play in renewable energy development? How does geophysics support infrastructure planning for sustainability? Which are all really good questions, related questions to my topic. So you can then explore all these areas as well, based on these suggestions if you want to. Now, in addition to that, what SciSpace puts on a table with different papers or book chapters or any publication material. Then it gives you the table in terms of insights, for instance, conclusions, methods used, research gap. And then these are actually from a table here, where it has this multiple elements that you could add to the table if you want to. Then it could, so here you have summarized abstract results, summarized introduction, literature review, limitations, contributions, practical implications, objectives, findings, future research, the dependent variables, the independent variables, data sets, population sample, problem statement, challenges, applications. So depending on the field in which you are, you could have and what you are interested in your systematic review, you could have all this. Let me just add, for instance, the results tab, right? So I add results tab, and immediately I have results from each of the papers. So for the geoscience for sustainable development, what are the main results? Geoscientists can contribute to solving society's physical dimension problems. They can also assist in various aspects of sustainable development, which are good results from the real paper that we are talking about. So SciSpace has been able to just extract that from this, and you can go and see a lot of papers that is gotten that from. So depending on what you are doing, you could look at multiple papers that it has done. So that is the first use of SciSpace in terms of extracting data, right? So this you could try your hands on again. Then the other one that I also like, which is really cool, is chat with your PDF. So let me see if we can upload something and then do that. That's the second tab. See desktop. Did I put it? Okay, so I have a paper here, water resources. Let me add that, and then let's do that. Okay, so it first uploads the paper to my library, my personal library in the SciSpace system. That may take time. So it takes time a bit because it has to upload the data, and my internet here is not good. So, but you could try your hands on that as well. Let's have a few minutes. Okay, so again, this is one cool tool for in SciSpace, because now that you've uploaded your paper, you can just go and ask any question you have, and it has suggestions on the questions you may want to ask. Generate summary of the paper. Do you want the results of the paper, the conclusions from the paper? Explain the abstracts of this paper. What are the contributions of this paper? Find related papers. Explain the practical implications. And those are all different things you will get from this paper. All right. And here, so let's look at the data set used. Let me use that. This is a nice example. So I click on data set used, right? What data has been used in this paper? And then the co-pilot, so the tool for this is co-pilot in SciSpace. And what it does is that it tells you all the data sources that have been used in this paper. So GRACE data, which is a gravity satellite system. Then it tells you airborne electromagnetic systems. That's another geophysical tool. Land surface model outputs, INSA and GNSS data, and in situ observations. But it captures that really well, right? And you see, as follow-up, it gives you possible questions that you may be interested in. What is the role of GRACE data in remote sensing? How does the EM help airborne electromagnetic surveys help estimate water table level? These are possible questions that could come from what you have seen in the paper. But you could experiment. Okay, my battery is really low. But I'm going to do, let me just do the last one before I run out. Then I'll join on maybe my phone if you have any questions to ask. So it's doing this. You can then go through the whole paper and ask any question you want without you having to, again, where I was talking about the time wasting, going through each paper manually to get the information you need. And then the last part here is the extract data, right? So I'm going to do, let's see. This 1 minute. So we have, let me see. So these are papers from, for instance, the Bosumtwi. So I load them in there. Okay, so I'm uploading all of them. Okay, it's still loading, so give me a minute. Okay, and then what it does is that it gives you, give me 1 minute so I can add myself on my phone as well, so that in case this one goes out, you can then ask me questions when I join on the phone. 1, 3, 7. Okay, so I think I've sorted that out. So what it does is that immediately it keeps all the papers that I've loaded, about 5 or 6 papers, I think, and then it compares them just like the way we did. The first one is too long, don't read. So it summarizes the whole, that's just a joke, by the way. So it summarizes the whole paper for you so that I don't need to read everything. And then it can present you the conclusions. It can present the results, just like the first part. So it could also add any component that you think you are comparing. So in this case, let's say you've already done your search. And as you've done your search, you've been able to get the papers that you want to focus on, extract data. You can upload all those papers into your SciSpace. And here, what is to compare, extract the data from all those papers. So depending on what you are looking for, like my framework I showed for my review paper, I showed what we're looking for in terms of maybe objectives and other things, right? So then what it then does is that you can compare all the evidence from this. So for instance, if I'm looking at, let me see, can we get methodology? I didn't add methods. Okay, so let me add methods. Now, the moment I add methods, now for all the papers, let's say I've already screened and selected as the relevant ones, it tells me the methods that have been used, which, for instance, with the paper I showed you, which we did manually, these are the things I'm interested in. The detailed petrographic investigation, for instance, for the paper, it tells me use detailed petrographic investigation plus micro-scale shock degree profiling. Then for the second paper, it says you use full waveform sonic logs, downhole geophysical measurements, zero offset and multi-offset vertical. So immediately this data that you want to extract from, even if there are 200 papers, that is easy to be done here. It gives you all that. Of course, I've given a warning that you always need to cross-check and validate what you are doing. But this simplifies that process of extracting.
Ebenezer,
Yeah, no.
unfortunately, my laptop has gone off as I said initially. Yes, but I think I've given you a good idea of what SciSpace can do. It's rather unfortunate, and I apologize for that. But like I said, I'm in the field somewhere in Benin, so I'm speaking from somewhere in the bush. So just forgive me. But you can take a look and play around with what I've shown you, and especially with the last part, then you don't have to spend time extracting line by line through each and every paper. Sure. So that's basically it. If there are any questions, I'll take them now. I think I can. Over to you, Ebenezer.
Yes, sure. I think that's fine. So I'm checking if there are questions that you can take. Then we proceed. So if you are online or in person and you have any question, you can quickly ask so that Dr. Zero is still with us. I think Someone has raised their hand online, Rashid. So we have some online, so let's take that. Then we come to the in-person. So first person, Rashid. So better still put your questions also in the chat so that we just read it out to Doc to answer them. Rashid, you should be able to unmute now and talk. I think there's challenge, so we are moving to Mary. Mary, was your hands up? Then if Mary's hands is down, Molly, let me see.
When wrong, they said that they have no question.
Hello.
Okay, yes, hear you.
Thank you very much. This wonderful presentations. So in my question, if we use an AI for the article writing, for article processing, so instead can we use for the when we publish, the publishers they accept for such kind of use by artificial intelligence. Also, what about the plagiarism if the article? That's my questions. Thank you.
Look, I don't know whether you hear him, but me, I was struggling to hear Molly.
That's not clear. Can you hear?
Yeah, I didn't really get your question. If you can repeat, or
okay.
you can...
My question is okay. My question is about what about when we use for the article publication? So can we use for an artificial intelligence? And also, what about for the plagiarism? And when we use for the artificial intelligence, is that acceptable or not? Thank you.
Dr. Siri, were you able to hear him? I think...
Okay, so I couldn't unmute myself. Yes, I heard him. I think he was talking about hello, can you hear me?
Yes, we can hear you.
I think he was talking about the AI plagiarism, right? If I got him right. Hello.
Molly, you can respond to Dr. Siri.
Yeah, so for if it's the plagiarism thing, so again, you see, I re-emphasize that point several times. AI tools are tools. So if you want to use an AI tool, you've already prepared your work. And for instance, let's say because we are from Africa and then maybe our English may be challenging, or from a country where maybe English is not the first language, or even maybe in Ghana, but you really don't have the time to write. Let's say you are not sure your writing fits the framework of, let's say, an American journal, right? You can make notes, and then you can, like from what I just showed in SciSpace, you've made notes based on, let's say, the methods you've seen, the techniques that have been used, the analysis that's been done. As you finish making those notes, you could now go to, for instance, ChatGPT and say, okay, look at these notes, looking at these notes and looking at what I've written, restructure this, maybe as a paper written by, let's say it's a methodology section, as a methodology written by, let's say, a professor in the geoscience department or in the geophysics department in Harvard or maybe in the University of Houston. Now, what will happen is that if you are doing that with ChatGPT, and I know I didn't treat ChatGPT today, but if you are doing that, what it will do is that it will take your material and restructure that for you in that kind of structure, like how the AI tool knows that people in, let's say, University of Texas geophysics department write, because it's going to check through online and look at what they write. And then, that's the good thing with computers. It can do that in a millisecond and structure your material. But the most important part of that is that it is taking your material. It's not like you just copied somebody's material. And because it's taking your material as a source document, the way to edit it will be different. And that one will not be plagiarism that an AI tool can detect. The usual problem we have, which a lot of us do, is that you go to ChatGPT and then you type, I'm writing a paper on let's say the effect of secondary school education on blah blah blah. Write the full paper for me. Immediately you do that, this is all on the AI tool. So what if it's whether it's ChatGPT or Copilot or any of the other tools, what it's going to do is that it's going to generate everything synthetically from its memory. And what you are most likely going to get is that you are going to get somebody's work that it has seen somewhere and copy and give you. But the approach I'm talking about is that make notes. And usually, like if you are a graduate student or a scientist, that's what we do. When you are doing research, you go to multiple papers and make notes. And I've just showed you how SciSpace can help you easily to extract the information you want from the papers. The moment you make notes of all those places that you want, you put them in a presentable write-up. And let's say you are not confident about your English level or the flow or the grammar. Now you can copy your whole paragraph and put that. And I'm emphasizing here, you are copying the paragraph that you have written. Put that back in ChatGPT or any of those other AI tools and tell it to write it in grammatically correct academic English, or you can even be more specific. Write it as let's say if it's a geophysics paper, write this like a geophysics professor in University of Texas or maybe Oxford University will write. And if you do that, the material you get is based on your work. So, and I think you should try this evening. Compare that, do that and compare that with just writing wholesale in maybe one of these AI tools that develop a paper for me on this. And then compare that with doing a few notes and then asking it to restructure these notes in that way. And just all of you should just try that this evening and you'll see the difference that I'm talking about. And that is where you can use AI tools as a tool and not as something that is actually doing the work for you. It is just a tool. And if you use it that way, the plagiarism will not be an issue. Even the AI detection algorithms will not pick it up because the source material is from you. And all the AI tool is doing is to restructure your source material for you. All right. I hope that is clear.
Yes, thank you. I think the next person, Eric.
All right. Hello, can you hear me?
Yes.
Okay. Doc, thank you for the presentation. You were like Confidence, Ryan, and SciSpace were not an AI initially, but now there has been integration of AI. But you made us understand that AI is just like simply a simulation of human intelligence. Usually, it's humans that do literary review in their traditional way. And now there's a system which is doing that or assisting us to do that, which we see that is a simulation of human. So why were you differentiating the confidence and there are tools as
No,
not
no.
being AI or
All right. So let me explain that. So these tools, some of them existed before, let's say, this whole AI bandwagon came, right? So SciSpace had, and so you could use logic response, other numerical models. You could use those to do the same thing because it's just correlation. What an AI tool does, and at the back of an AI tool, let's say machine learning algorithm, what it does is to find correlation. You see, so basically, it's not like it's if I want to explain it, it's very minimum. It's like drawing a straight line curve between two variables. So if I draw a straight line curve between my data points and I now know the correlation, anytime I have X, I can find Y. And an AI tool only does that in a complicated way. By saying that anytime I see these words that you've typed, I know that they are surrounded by these other words. That is all we do. That is all an AI tool does at the basic level. Now we have more complicated algorithms that can do that. And then they can also find relationships that are more complicated than a straight line. A straight line is the basic relation between any two data points, right? But you could do, for instance, with statistics, you could do this thing. You could do an exponential curve. You could do a power law representation. You could do complicated numerical models. This existed before the advent of AI. In fact, that's why a lot of some statisticians and some mathematicians will tell you AI is not a new thing. It's been there for several years. So that's the only reason why I'm differentiating between that. So the fancy new shiny thing that has come as AI is what I'm talking about. Not that it wasn't there at first. There was always a way of simulating, even if you find a straight line relationship between any data points, you're just trying to simulate how do we call it? The way humans understand the world. But with this one, it's more complicated. So you can find any relationship like a human being. For instance, if you have the moment we teach you something, you can find more complex relationships without us having to teach you again, right? And that is what AI tools, that's what they do. So the differentiation is not really that big. I'm just trying to make the point that those tools were there before, let's say, all this AI bandwagon thing came, and they were using other numerical methods behind the back in the back end. But now they've infused AI and machine learning into them. SciSpace was good. I'd used it before, let's say, the advent of ChatGPT and then the integrated ChatGPT. It was good, but it wasn't this super good. Now it's really on steroids, right? You couldn't do this extraction of data with the old system, right? You couldn't do the ask your PDF thing with the old system. You could search for relevant papers though, just like Google, but you couldn't do now like the sample I showed that you could just upload your paper and then have the AI to go through your paper and tell you what data set to use, the population size, the conclusions, the results. You couldn't do that before. So that's where it's been it's been pumped up. So it's better than it was previous. But it's not really a big deal in that. All right. I was just trying to differentiate. Yeah, thank you.
Thank you, Dr. So I think there's no more questions. And if there's any question, I'm sure.
I can see that somebody is asking if they will get free reputable journals. Look, there are a lot of, how do you call it? Most of the journals on Elsevier and Wiley, even Springer, some of them are free. Even for even Springer Nature now, they have how do you call it? They have waivers. So waivers are when they tell you they actually give you a concession. So I think just this year we published a paper in one of the Nature journals, scientific reports, and the cost was about 2,000 something, but it was totally waived. So some of these things you should find out from your librarian. You can get them, even if they have a price for open access. Just talk to your librarian. They can find a way of giving you waiving the whole thing, and then you publish for free. So as for getting paper journals to publish in, don't be afraid. Just search. If you do a research, some of the Elsevier journals, if it's not open access, then you don't get to pay anything. Or the only thing is that when people need to get to those papers, they need to pay. if you want open access, some of them, Scientific African has a waiver for a lot of Africans. So that's done. A lot of journals have that. Write to the editor and tell the editor you want to publish, you are from a poor African country, you don't have money. Of course, write that in a better way, but write that and you probably get a waiver. So the journal money should not be a problem, right? Yeah, thank you. Ebenezer, I hope I can go now. I need to go get back to the field. So if there are any questions, you could share my contact, send me an email. I think it's in the PDF. So if you share if you get to share the material I used, they can contact me at any time. Thank you for the opportunity, and guys, I hope you enjoy the rest of your sessions. All right.
Yes, thank you very much, Dr. Thero, wherever you are, for your time and your wonderful presentations.
Hello, everybody. I hope you can hear me. Hello, everybody. Can you hear me? Online and in person. Okay. No response from online yet. Okay. Thank you. Response. Oh, fantastic. Thank you. So we have, we're currently on our lunch break, and that's going to span for roughly 30 minutes. So we go for lunch break of 30 minutes, and then we come back to perform the hands-on activity for risks of bias assessments. And of course, during that 30 minutes after lunch break, if we have any questions, especially regarding confidence or systematic literature search, we didn't have opportunity to ask questions, we can ask questions. And of course, within this time, if you have issues with installation of Stata, you can also let us know. The lunch break is not compulsory, so if you can stay back and do a couple of things, that would be fantastic. Because when we come back from the break, we will start the meta-analysis, the second meta-analysis session. Thank you very much. Please let us know if you have any questions.
want to acknowledge School of Postgraduate Studies, all the officials in each of the institutions. Unfortunately, anytime they came around, we were so busy working, and they were so excited to see you on your laptops. They didn't want to distract, so they didn't yield to us schooling them here to say anything. They said, no, let them do the practicals. We won't interrupt. And director and deputy director, School of Postgraduate Studies, Arts Grace, and all the people involved. We appreciate their efforts. Can those online hear me? They can now hear me. So we acknowledge the institution. University is no mean institution. I hear we are about 4 globally now, right? And I'm an alma mater, so I'm really proud. I work with my head up, and kudos to University and making this happen. Then we also want to acknowledge Fortune, the young guy with a big vision. He's able to dislodge all powers to get this thing to happen. In fact, if he had not been as stubborn as he was, this thing would not have happened, because pulling me, pulling Nadia, pulling everybody else to get this thing to come to be, I think he deserves an applause. He really deserves an applause. And it's not just people that say in Ghana to you, it's people in Rwanda, Uganda, South Africa, I think about 7 or 8 countries, right? Pushing people from the bush to present, I think they are in an air conditioned place, right? I don't know how he does it. I keep asking myself, do I owe this guy something? Why is he getting me to do all this running around? This morning, my feet was sitting and I was saying, juggling my private practice, clinical work, lecturing, exams. I have like 5 classes I'm handling. I don't remember doing so much walking around in recent times that he's made me do in these past 4 days. So I think he deserves applause. And then I can't even finish acknowledging people. Julia is in a different timeline. She's not sleeping. She's coordinating everything. And yesterday, I remember talking to her at 3 a.m. and she telling me, you know, I was awake the whole time. It's just 3 a.m. and I haven't even slept. And I have to catch a nap and prepare for the next session. I said, oh, I slept. And when I woke up, we were all lying. And so you were asleep. And she was still busy trying to check whether the facilitators are ready, they've got their materials, whether you are getting your links and everything. Every single complaint Julia is trying to get us to resolve it. Even those who couldn't afford to pay, she was looking at how we can get them to also benefit. So Julia, God bless you. And all our facilitators so far, and Monica, I'm not leaving the list for last. I can't finish the list, honestly. I will end and fall flat on my face. If Ben doesn't sleep, he too is another gig. I don't know how it's doing. All our IT staff coordinating across the various continents, sending materials left and right. Last time I checked, we had someone from Sudan joining us, and I was like, Sudan wasn't part. Where did this person get in? And he's doing it. Even the presentation of our procedure dates, he's working on getting you your assignments done, even as I'm speaking. And he also deserves some, because let's give him a round of applause. Dr. Akisi is not here. Dr. Khaled too is not here. It is another amazing guy. He's with the Ghana Hub. He's our program coordinator, and he's also been going up and down. At a point, he was like, I'm running another workshop, and Fortune says we should do this one. How do I juggle the two? I was like, well, do you have to do right now? He says, okay, you give me some time. And the next minute is produce some results. So we have so many great people on this platform, and we have how many, 5 or 6 institutions, right, collaborating to get this work. And I'm very optimistic that this will not be the last of such collaborative efforts. In fact, all the feedback you are given to us will be channeled into possibly another workshop. And I hope that we'll all be able to participate so that by the time we are through with this capacity building, if not, I can count as many research publications as possible. And OTA is always providing grants and scholarships and funding for research. So please make the assignments a personal priority. I'm a beneficiary of one of the grants. And my project's vision was to do things like this, to train. I started out looking at just my junior police, younger residents, because I went through biological science, did a little bit of research, did a little bit of work at Noguchi Memorial before going back to medical school and then going into postgraduates. I love research. I fell out of love with research. Then I fell back in love with research. And then I discovered that our training is such that Ghana is presenting less than 1% when it comes to the global front in terms of research publication. And right now the gold mine is data. And the sad part of it is that we have, this one I shouldn't even be going The sad part is that we have foreigners, non-Africans, sponsoring us to do the research. Then they own the gold, which is the raw data. And then when you want to have access to the gold, because you are not a primary investigator, you're not a father, okay, you're a secondary, then it's like you don't get the full value of it. So my passion is that each one of us will represent a publication and a series of publications. And until that dream is achieved, I think fortune will be able to push me out of my comfort zone. So I'm applauding every one of you for putting yourself into it, not leaving out those online. Let's make Africa proud so that when we stand on international platforms and we are speaking, we own our data, we own our findings, we tell the African story the way it should be told, and we develop our own models. A lot of the models of care we are using, we have to adapt it, we have to validate it for it to work. Anytime I sit in my clinic, I have to diagnose patients, I have to use tools, and the tools are not validated for the African child, and we still have to use it. I hope that programs like this will continue so that we change the narrative in health, in commerce, in agri, in all the areas, because we're born with a goal in our hand, right? So thank you so much. I think by now I've exhausted your 7 minutes. So we'll take group photos. This is Dr. Pearl speaking. Those of us in person who stepped out yesterday to the left outside, right, to take the pictures, and we encourage all those online to put on their videos and take a screenshot of attendance. Thank you so much for being with us. We'll continue after our break time is up. Great.
Okay, let's put on our videos for quick. So quickly, let's do that. Let's put on videos. Okay, thank you very much. We are done with the
Hello, everybody. Can you hear me, please?
I should add another team members. So that we can pass along this.
Hello, can you hear me?